Now before moving any further, let's talk about images. So what are images? Images in this case, if you see this variable called image, it's actually a numpy array. So what is a numpy array? Numpy is a library that we have installed along with OpenCV. It is a library which handles metrics. So what does it have to do with images? So images, if you see any image, that if you consider my screen as an image, then you will find it has y-axis, it has x-axis. So if you zoom one particular image, mm, let me try to open this once more. Okay. Okay, why it is too dark? Let's take another shot. Okay. Okay, so I am going to move that here. I don't want to. Okay, so if you, okay, let me try to open this. If you see, it has an x-axis, it also has an y-axis. You can also see that in the bottom status bar, which is showing us the average color and average intensity of each and every RGB colors, and also showing us exactly the coordinate of our mouse pointer. If you think about it carefully, you can think this image as a two-dimensional matrix. So basically it's a three-dimensional, so we'll look into it. If you think about it as a two-dimensional matrix, then each and every element in the matrix is our pixels. So if you have a very high resolution camera, it has a very large or very huge number of pixels, and it will have a very large matrix. And how this color information is coming, each and every cell in this matrix will have three values, so that's why it's basically 2 x and y. And if you think z axis as a color axis, where you have red, green and blue information specified in this. So you can see, if I move my mouse pointer here, then okay, so if I move my mouse pointer here, it's showing me the color of that particular value. So it's almost white, that's why you are saying RGB everything is maximum. uh, and by maximum I mean 255 is the maximum value of the color that we can get, 0 is the minimum. So if you go here, if I move my pointer to any of these, you can see values are almost very less. Blue and green are almost 0, red is getting a little bit of value here. So you can see the x and y is your position, and you can think of z as a color axis in your matrix. So let's try this theory. Let me stop the, press q here, and if I print image, so you can see it's an array. So this symbol means it's a numpy array, and you have one, two, three brackets. So three brackets means, first bracket you can see three color information, red, green, blue, and that is enclosing, that is our one dimension, one single dimension, that has been repeated in another dimension, which is this, and it is repeating continuously. So it is, let's say, one axis, and it, that entire axis is repeated in another dimension. So first the color, then it is moving through through a particular axis, then that axis is getting repeated in another dimension. So you get a three-dimensional array. Now we have an understanding what is an image is. Let's apply some filters on that image. The basic filter that we were going to apply is convert a color image to a grayscale image. So what that will do, it will eliminate the color dimension and it will replace this color dimension with one single dimension, which is only the intensity value of that color or that particular pixel. So the intensity value is like average of all the pixels. Let's create a grayscale image. We will call it, we are going to call it gray equals cv2 dot cvt, and press tab. It will show you the available options. So we want to convert the color, so cvt color, and we are going to supply the input image, which is our color image. And now we are going to specify what kind of color conversion that we are going to do. So it is cv2 dot color, press tab. It will give you the options color. So it is underscore b color, press tab, underscore b g r. So basically OpenCV image stores the image in a blue green red format, although I'm saying it in RGB, but it's actually by default it's converted, it captures it in a BGR format. That means your first column, first element in your color dimension that you are seeing, which is 248 currently, is actually your blue element, then your green element, then your red element. So we want to convert this BGR format to gray format. Again tab G gray. This will convert the BGR colored image to gray image. Now let's display the gray as well in another window. cv2 dot im show, and we are going to call this gray, and we are going to pass the value gray. Okay, let's see. Okay, so we have our gray window and we have our color window. We have both of them. So this, if you see, it only has intensity values and the xy coordinate, but this one has color values and this one has only intensity value. So when you see a gray image, it does not have any z axis because it's only one value, so it will be only xy and the value of that coordinate. So this is our, this is our, this okay, so now we know how to convert a color to gray. Let's do something interesting. Let's convert, let's see how we can get the edges of the of this image. uh, Basically that's an edge detection. Let's call it edge, and we are going to call cv2. So there are different libraries for different algorithms for edge detection. So we are going to use is an algorithm called Canny. Let's supply the gray image. Whether you only supply a gray image in the edge detection, it doesn't work with color. You can apply color, but means you can apply edge detection in each and every layer of the color. Like you can apply on only the red layer, or only the blue, or only the green, but you cannot apply on simultaneously all of the three. So that's basically, you don't need any, I don't see any reason to apply edge detection on a colored image. You will get the same result anyway. So let's get the edges and let's print it, or let's show it. So I am sure is the OpenCV way of printing stuff. So edge, let's call it ed edges or whatever, and let's see if we okay. Let's stop the loop first. Once we have stopped the loop, then rerun the loop. What happened? Okay, can he text? Okay, so can he text to argument? Okay, so it uses two more arguments. One is the minimum value, one is the maximum value. Okay, so this is basically a thresholding where it decides what is the minimum threshold for edge to be an edge, and what is the maximum threshold after which it will not decide it as an edge. So this is something that you can play with, but by default in the OpenCV document we can see that they are using 100 and 200. If we run this again, you can see now it's giving me the edges. Hey guys, that's all for this video. Please don't forget to like and subscribe, and I'll see you guys in the next video.